Hi, here's Maciej. Today I would like to show you my recent open source project. It's a moisture monitor, so you can use it to monitor, for example, moisture level for your plants. I've been using it for the past 2 months and it turns out to be quite useful. So it does a really good job, it's precise and it shows values that make sense. Now those LEDs here show the level. Currently we are at totally dry where it's not in the soil and this is wet. When I hold it with my hand, the moisture level will increase to about 3 from 7. It's based on Atmega 328, 16 MHz quartz, multiplexer, few LEDs and few buttons, and this battery. It runs on such 3100 battery for about 2 months. Well, depending on the brightness of the LEDs and 20 other things, but in my case it does it for about 2 months. Now we have a few buttons here. The first one is reset. It resets the whole things and it resets the settings for those 2 buttons to default values. Now this button here changes the brightness of the LEDs. When I press it, it will light up all LEDs just to show you what is the brightness level right now. So if you can see, when I keep pressing it, it decreases. Now I will reset it to go back to nominal values. Maybe increase it a little bit so we can see better. And now we will go about the calibration. So when I press this button only once, it will show you not the moisture level, but the calibration of the sensor, which is in the middle. You see the calibration is in the middle. Now I'll stick it into soil, which is a bit wet, not much. Jesus, that goes. I had to make sure that it's actually touching soil because I was putting it on and out, in and out, and there was a space between sensor, so didn't get proper reading. Now it is in there and we have 3 from 7. When I press this button only once, it will show me the current level. Oh, now it goes to 2 because I pushed it. So the current element is in the middle, but we can say, okay, I touched the soil with my finger and I have the impression that it should be in the middle. So we can press this button a few times and increase the reading, right? So let's press it and you will see now it shows the current moisture level, which is in the middle, but we press again, it increased by 1. You see now it shows more and we'll press it once again, so we are here. That is great. And now I just remove the battery. Let's start from the beginning. But the problem with the battery is that it's in a plastic box and I used a hot air gun to solder Arduino and that bound this holder for the battery, so it's not holding very well. Let's increase the level once again. Another reading is in the middle. So maybe you have noticed when I pressed this button, it took about 2 seconds to update the reading. The reason for that is that when you press a button, it drops the readings of the sensors for 2 seconds. Because this takes a few milliseconds. I mean, the reading of the sensor takes a few milliseconds. And when you press the button at the same time, it feels laggy. So the software just disables the reading for a few seconds when it notices that you pressed a button. Let's press it a few times, and we will see what happens. So it's increasing the reading, it's increasing the reading. Now it's at the maximum, and now it will go in the middle. And now when I keep pressing, it will go down. So you can decrease the reading as well. And now it's at lowest point. Now I'm not sure what happened. Aha, okay, it showed me that it will reset. Once again, we go up, we go up, we go up. We go back in the middle and we go down, we go down, we go down, we go down. And once again, we are in the middle. So this is how you can calibrate the sensor. Now, this LED is for now on all the time. but I will show later on that it will also go off and on. Well, because the whole thing goes into the sleep mode every few seconds, so that you can really run on the battery for 2 months. I have to put Arduino into the deep sleep and wake up every few seconds just to preserve the battery so it holds for longer. And the LED right here below this one show lights up where it's blinking actually when the battery level drops below some defined value. I will show you that. Jesus, that worked beautifully. I will show you that in the second video. We'll talk about how we can program it, how the software is built, and how you can calibrate a few things, because you will have definitely to calibrate the sensor, because depending on the paint that you will use for it, it will just change the calibration. But calibration is really super easy, but probably you might have to do it. I mean, you can use this button and maybe it will get you somewhere where you can decide, okay, I'm happy with that. But if you want like to have the really precise readings, then it's possible to calibrate it to have really better results. Okay, we will see us in a few seconds with Arduino IDE, and I will show you how to program this thing and how the software works and things like that. Okay, now we will talk about software part of this project. For that, I have connected it into to my PC. This is simple USB to serial adapter, and there is a header on the top of it where you can directly connect this adapter, like so. Let's have a look. So the first thing that we are about to do is the calibration of the internal voltage reference. So you should calibrate it if you, I mean, why do we need an internal voltage reference? We need to pick up the battery level so that we can switch on this LED when the battery level drops below some value, and also it's been used as a reference to measure the moisture. Okay, let's see what is the battery level right now. Is the camera picking it up? Yeah, it does. No, it does. $416. All right. So what we are going to do, we need to enable logger over serial port to see what is the voltage level from the Arduino from the Atmega perspective. For that, we go to, first we need to figure it out what is the serial port speed. And that's not very straightforward, because what the software does, when the program starts, it switches the CPU frequency from 16 megahertz to 2 megahertz. So it's divide the frequency by 8. Now we are setting the serial speed to 38400, but as we divided the clock by 8, we have to also divide the speed of the serial by 8, which gives us 4800. So we have to set the speed of the serial to 4800. And that's the first thing. There's also another variable that we need to change in order to calibrate it properly. I'm just looking for it. Okay, it's already N1. It's a minimum voltage change. So the software that I have written works in the way that it's a pickups the voltage change, but only at a certain level. And usually you would put here like, I don't know, 100 milliamps. So it will pick up voltage changes only over 100 milliamps. But as we are calibrating right now, so we would like to pick up every voltage change. Why do we want to pick up only larger voltage changes? Because if we pick up every voltage change, I mean, every measurement has a slight difference. I mean, it's not perfect. Now, if you are with the moisture level, like on the corner between, let's say, level 3 and 4, and you pick up every smallest voltage change, then can cause a flickering. So when that will jump between level 3 and 4. So you don't want to be. So you don't need such precision when you are reading voltage. 100 milliamps is okay, but for calibration you would like to have as good precision as it is possible. So we are changing it to 1 temporary. Later on, when you will observe the flicker of the LEDs that are jumping between one level and another, then you know that you have to change this variable to avoid it. Okay, so we have changed the voltage level, and now we have to enable the proper log line. I know that I have to go to a class called VCC monitor, because that's the one that will output the voltage. And this is the line that we are interested in. And there are two constants that have to be enabled in order to log occur. First one enables log in general. And the second one enables log for this particular class. So you can enable and disable log for every class. The reason for that is that the index is broken. The reason that you can enable a logger for each class separately is that you are just interested in one particular type of events, and you don't want to see everything. I mean, it will be just too much, hard to read, and so on. So you can enable and disable logger for every particular class. Okay, let's upload it and see what we will see on the console. It's uploading. Done. Well, we are at 3.7 volt, and as I recall correctly, we should be at 4.1. So there is something wrong with the calibration. There is this variable here that we use to calibrate. That's the default voltage reference value. And I set it to 1000, and default for Atmega is 1110. So what you have to do, you have to measure the battery level with the multimeter and play around with this variable until you get as close as possible to what the multimeter is showing. Now we will upload it once again, and probably you won't have to touch it because 1100 is sufficient, but depends on your version of Atmega. Maybe it will require a little calibration. We'll see what we'll get in our case. Almost perfect. We were at 4.18 and this is 4.16. I mean, it's completely sufficient. We don't need that high precision anyway. So we can see the voltage has been calibrated right now, and we are happy with it. Let's go to Arduino log and disable the logger for the VCC monitor, because now we are going to calibrate something far more important. So the thing is that, so what the software does, it has to know the voltage value when the soil is completely dry, and then it has to know the voltage value when the soil is completely wet. So those are two opposite values. And now it maps the red voltage from the sensor that is between those two opposite values to level 1 to 7. It's a simple mapping function that takes 5 parameters, right? Minimum and maximum value between it, and the destination minimum and maximum value. So input and output. And the problem is that with the battery charge, with the battery level, the minimum and maximum values are changing, and this is not linear function. So I decided to go for a simple mapping table, because that's the simplest thing that you can do. And before we start calibration, we have to enable the logger. We have to change this voltage level. We have to set this minimum voltage level to 1, but we've done that before. But in ArtLog, we have to enable the logger and enable the logger logMD, because this is the moisture driver. Let's see the moisture driver in here, but not the header file, but the CPP, which is that. And we are interested in this line. It doesn't jump where it should, but we can find it too. I will upload it and then we will go through the meaning of this log once we see it. What? If you have 25 cables, something might get loose. Now we are getting somewhere. Great. What do we see here? I like to see the table. I will hold it with my hand so that we have some moisture. And that is really great. Okay. I removed the battery. Sorry for that. We have to start over. Doesn't work without battery. Okay. Now let's stop it. This is the battery level that it's read right now. 4.1 volt. This is the reading of the moisture sensor. So the moisture sensor now is at 2.5 volts, and that is being mapped to level 3. You'll see the 3 LEDs are on. So 2.5 volts results in the level 3. And now we are at 4,100 milliamps. And that leads to this row in our table. So you can see that 4,100 has a minimum and maximum. Well, it's a dry and wet level at 31 and 17, and this is 31 and 17. So basically what this log shows is current battery level and the row that it found in the table, which is this one, based on the battery level. So for 4100 it goes in here. If it will be 3.6, it would go here. So it shows you the voltage level for the dry and wet soil, the current reading, and the resulting moisture level. Now what we have to do, you have to remove the battery. I won't do it right now, but you can do it by yourself. You have to remove the battery and connect the sensor to power supply where you can adjust the voltage, and you have to go in 100 milliamps steps. And what you have to do is, like, let's say that you will stand with 3.3 volts. Now you have to adjust your power supply to 3.3 volts, and do not use multimeter to read 3.3 volts. You have to see the 3.3 volts here on the output, because it has to be the voltage from the Arduino perspective and not your multimeter, what Arduino sees, right? So adjust the voltage, let's say to 3.3 volts on your power supply. If you are getting 3.3 volts here, now stick the sensor to the dry soil first. You have to start the calibration with the dry soil, not with the wet one, because the moisture will get into the paint and then you won't get a proper readings for the dry soil. So we are starting with the dry soil. You stick the sensor into the dry soil like so. Set your power supply to 3.3 volts and pick up this middle reading and put it in here. Increase the voltage to 3.4 volts. Take the reading in the middle and put it here. Go and go and go at 3.9 volts. Copy the value from the middle in here, and so on and so forth. So what you want to do, you want to stick the sensor into the dry soil and go over each possible voltage level and put in the reading of the sensor into that column, which is the dry level. Now repeat the process for the wet soil when you move the sensor to the wet soil, and go again through every possible voltage level. That will give you a calibration for what you have built. I mean, you can have a different PCB, different materials, different paint, and whatever it is, it will really influence this calibration. So you have to go through it. Otherwise, you might get some strange results. And what is quite important, let's see what is the voltage difference. I mean, you should get like around 1.5 volts voltage difference. How much is this exactly? Okay, around 1.5 volts. So if you are not getting a voltage difference between dry and wet of at least 1 volt, there is something wrong. Probably you used to thick paint, or there is something wrong with your PCB. So you want to have the readings of the dry and the wet level as far apart as possible, because then you have more probing points in between, so the readings will become more stable. Okay, when you've done that, you are fine with the calibration. Then you have to bring that back to something like 100 milliamps. Turn off the logger. That's really important, because otherwise it will consume battery, and really you don't need logger if you are not reading the values. Okay, I will just upload it for myself, and now we will go through the software. I will show you how it is working actually. So let's go to the main class, which is this one, and we see a bunch of the classes here. Each of these components has its own responsibility, but as you can see, there are no direct references between components. So the components itself are decoupled over a message bus. So basically every component can produce an event and can receive an event. They do not communicate directly with each other. They are decoupled over the message bus. So to see how the communication between components takes place, you have to see what events we have, and for that we go to the event bus.h. There are all possible events. Let's just go through some events and we will see how they are being handled. Now, event bus fire. Okay, so this is the place exactly here which produces the event's brightness change. Whatever it is, I mean, it's on next level. Probably a button has been pressed and it decides that the brightness has changed. So it sends an event brightness change with the new brightness level. Now, who is interested in that event? Let's CPP is interested in that event. Jesus, I can't jump into the methods. The index is completely broken as crap. But this IDE is really... I've been developing software for like 20 years. I never seen anything like it. It's really not meant to work with multiple files. But anyway, we have to live with that. And going back to where I was, at least free text search works fine. Okay, the brightness once again. So we are interested in the brightness change event. And let CCP is consuming this event and it writes the value down. So the let CCP controls those two LEDs. So it just remembers the new brightness level, not very interesting. And now moisture display also reacts to these events and changes respectively the brightness. So what you can see here is like every class can implement this onEvent method, and it will be called when every possible event occurs, and you have to pick up with if statement the event that you are interested in and react to it. This is just temporary solution. I'm going to change it. This if statement will disappear, and in the next software release we will have something like, just looking for setup method. Each class has a setup method. I will show you. I would like to avoid to have this if statement instead of this if statement. So basically there's a method that is being called on every event, and you have to pick up with the if statement the event that you are interested in and react to it. Instead of having this method, we will have something like on the setup method, we'll have something like event bus register this, something like this. That will be the next software release. So basically every class will be able to register on the particular event, and will provide the method, and the event bus will directly call this method. So you won't have to have this if statement. But for now we have the if statement, so let's stick to what we have here. Okay, let's go through another event, because the first one was a little bit messy. Let's go to another event so that we get a feeling how this is working. Now go back to event bus and pick up another event like button brightness. What is button brightness? First we are looking for EB fire. That's the place when everything starts. So we are in the class buttons CPP, and read buttons, it's a function that runs probably in a loop or something like it. And when this pin is low, it just fires the event button brightness, which means someone has pressed this button right over here, right? That's it. Who is interested in that button brightness event? Let's CPP. It's the one that drives those two. Okay, what it's doing is it blinks few times, this blue LED. So LED CPP is interesting in this event button press because it blinks this LED few times just to indicate that we have, this is just an acknowledgement that the button has been pressed. This is all about it. So LED CPP reacts to the button press just with a blinking. Power saver also is interested in the button press. What it does, it postpones the standby by 20 seconds. It's in the configuration value. So when you play around with the buttons, you don't want this whole thing to go to the deep sleep mode. So the power saver is interested in this button press event, and it postpones the standby. And the probe driver, that's also something we will see about in a second. What we will talk about this function in a second. I don't want to talk about it right now. And the brightness manager is also interested in this button brightness event. That's actually the most important part, because what it does, it calculates the next brightness level and sends another event that the brightness has changed. So the brightness manager just increases the brightness level, or when it's a maximum then goes back to the minimum and sends an event with the calculated brightness. So this is how this is working. So when we press a button, the event will be dispatched that the button has been pressed. A few classes react to this event, and they send another event eventually. Now, there is one more thing that we like to talk about, the for loop. Well, as usual in Arduino, everything runs in a for loop. And this is where make calculations take place, and we didn't talk about for loop. And as you can see, the implementation of the for loop is nearly empty. This is just delay. What the for loop does is sends an event cycle. And now every class that is interesting to this periodic event that occurs every time when we iterate can react to this event cycle. So let's see who is interested in the event cycle, right? Okay, LED does something. What is it doing? I don't know, updates the brightness or something like it. Power saver is interesting to the cycle event. What it does, it can put the whole thing into deep sleep mode. And the probe driver is interested in this cycle event. And what it does, it sends every 2000, should be 200. No. We jumped. Sorry, that's the broken index. We jumped. We jump into wrong place. I have to look for it. Wait a second. Probe driver. Okay, that's correct. I'm here. Okay, so what is happening right now? So the probe driver receives the event cycle, and now it receives the event cycle and now sends a new events probe, but it sends this event every 200 milliseconds. And that's really important thing. Let's go back to where the events are being sent. I mean, this logic is something else, but we are just interested in this one particular thing, that not to complicate things. So the probe driver, this on-cycle method, will be called with every iteration, and it will send every 200 milliseconds this probe event. And that's quite important, because what probe does is like VCC monitor updates the voltage reading on the probe event. So not with every iteration. We read a new VCC level only every 200 milliseconds. Now the probe, the moisture driver also, okay, my battery is running low. The moisture driver also reads the current moisture level on this probe events on every 200 milliseconds. The reason for that is that the reading of the internal voltage reference or the reading of the moisture sensor takes like a few CPU cycles, so it introduces lag. And we don't have to measure, I mean, the moisture level like every millisecond. So we can postpone it, we can measure it every 200 milliseconds, so that when you press on the buttons, so that does not introduce lag. So this is how it's working. So the cycle event is being sent with every loop, but probing takes place only every 200 milliseconds, because the probe event will be dispatched every 200 milliseconds, and all components that are probing analog values trigger on this probe event and not on the cycle event. And the last thing, I would like to show you this deep sleep function that was disabled until now. Now I will enable it. So here's the thing. If this device is going to run on the battery for about 2 months, we have to do some tricks. I mean, there's no way around it. So I'll put it into the deep sleep every few seconds for some period of time. Now you see everything is off. Even this blue LED is off. Now it's on, which means it's wake up, and now it goes to the deep sleep again. Oh, that is really great. Let's start over. And now it's awake. Now goes into the deep sleep again. And it will wake up in 8 seconds. And when I play around with the buttons, it will postpone the sleep for about 20 seconds because this is how it's programmed. And you can configure it over here. This is the period that this is sleep time, which is 842 on 1 second. This is the standby time with normal operations. On every 4 seconds, it goes to sleep for 8 seconds. Now, when you press a button, you postpone the sleep time for 20 seconds and initially it will go to sleep after 10 seconds, which is not exactly true because the calculation in milliseconds takes place when it runs at 60 megahertz and it goes to 8 megahertz, so it's not that precise. I mean, instead of, I would say that it's like less. Didn't really bother to calculate it, just increase the value until you are happy. That was the last feature. I mean, you can disable this deep sleep mode, it will just shorten battery life, so up to you. Okay, thank you for watching and have a nice day. Bye.